So welcome. Tonight for TRiRODS, we're going to have Jonathon Anderson, who is Associate Director of the University of Colorado Boulder Research Computing. He's going to talk about deploying logical quotas along with iRODS at CU Boulder for the PETA library. Thanks, Jonathon.
Thanks, Terrell, and thanks, everyone. We're pretty new to iRODS still, so I've got some stuff in here that's just background on a little bit on research computing and a little bit on what brought us to this state. So I'm sure everyone there is quite a bit more familiar with iRODS than I or anyone here is. So if you see something that we're doing and you're like, why are you doing it that way? Would love for that question to be raised, because there's a good chance that we don't know that we shouldn't be doing it that way. But of course, any other questions about our experiences with the two main newish components that are in our deployment being NFS Rods and the logical quotas, I'm happy to talk about that, or really anything else that comes up. So like Terrell said, I'm Jonathon Anderson. I'm with the research computing group here at CU Boulder. We primarily, at least people primarily think of us as an HPC center. We run a couple of compute clusters, one as kind of an NSF grant, and the other is a condo system that we aggregate from contributions from a bunch of different users. Then we also run a research data storage system that we call the PETA library. And that's in kind of two parts that we'll get into. I'm gonna skip this one then. Here we go. So the PETA library has been in operation for about 8 years at Research Computing. It predates me by a fair bit. It starts with the tape library that you can see. I have, yeah, sorry, I've got two slides here on my screen, so I'm getting confused. The tape library on your right is one of these kind of standard two-frame IBM tape library things that was expanded at one point. Currently, it still is accessed using hierarchical GPFS and TSM file system, sorry. So users primarily interact with the GPFS file system, and then their ILM policy management stuff stubs files off to tape and does it relatively transparently. And then on the left is a DDN grid scaler cluster based on an SFA 10K that we kind of got on a backyard deal. I don't really know how this happened. Again, it predates me, but my understanding is like DDN had a used one lying around and had a special deal. And so it ended up in our racks. And so the one on the right became PETA Library Archive, which we mount pretty much just on like Globus transfer nodes and login nodes where people can put data that they want to keep but not necessarily use at any given point. And then on the left is PETA Library Active, which we only mount it over NFS, but it's relatively performant, and we give access to that from all of our compute clusters, and especially our condo users who don't have a dedicated Scratch environment have tended to use PETA Library Active for their kind of active data sets and things like that. We sell access to both of these systems at a terabyte per year rate. What I like to say is that our competition isn't Amazon or any cloud service, but going out to Best Buy and buying a hard drive that you keep on your desk. So that's where we try and match price points. So what we end up doing is we buy or pay for infrastructure somehow, and then we base our storage rates around the price of the media that goes into it. The goal is to get researchers to do the right thing with their data, which is kind of a theme with using iRODS as well. But rather than putting it on a hard drive that doesn't even have an enclosure and then keeping it in a drawer, we want them to have it in a RAID array that we help them manage and replicate and things like that. And then most of our users interact with both of these systems at some point, certainly the archive via Globus. We have a number of users that use Globus shared endpoints in particular to share data with users at other institutions. So over the last, I have in my notes year or so, but I am depressed to admit that it has actually almost been 2 years. We've been migrating our storage from those infrastructure bits to these that you see on the screen here. So on the left is a series of SAS enclosures. They're relatively standard 60 bay HGST enclosures. In fact, I think they are the same enclosures that are in the 10K, just direct from HGST instead of through DDN. And then those are aggregated using ZFS, and then we run BGFS on top of that. So ZFS for storage, and then we have a pair of servers that are providing metadata for BGFS that use XFS on the disk. And then on the right is our new Spectra T380 tape library. So that has 4 LTO8 drives, and we use the either LTO7 or LTO8. I see it said different ways. The Type M media, that's an LTO7 cartridge that's formatted with the LTO8 format. So we get 9 terabytes of cartridge on that, which is kind of cool. And then above it is a StrongBox LTFS storage appliance. So if you're not familiar with this, it has some local cache, and you write into an NFS or SMB share or read from it. And then it handles basically stubbing that out to tape. I think it's actually using a database inside. There's no real stubbing going on in the file system, but it stages those files in and out of tape, depending on the fullness of the cache. Yeah, and then just by happenstance, the 2 servers that are above that are database servers that ended up holding our iRODS catalog, which is a whole other story. So the main thing that was giving us problems, even with the legacy archive, is that so the way we like to hand out this storage is we want to create a directory and then set a maximum size for that directory. So in GPFS, you do this with file sets, where you create a file set and then you junction that file set into your namespace somewhere, and then you can set a quota on that file set. It effectively is just another bit of, or whatever, another ID that gets attached to every directory and file, just like UID and GID has a file set ID. But then everything within that sub namespace gets that file set ID, and then you can track quotas on it in the same way that you would track UID and GID quotas. CFS does this a little bit differently. You create a data set, and then you can set a size on that data set, and that's exposed as a file system. So we can do that in traditional file systems, but when it gets hierarchical, it gets messy. So even with GPFS and TSM together, when GPFS stubs data off into tape, that data comes off of your quota and no longer impacts your quota. So historically, we had a series of terrible scripts that we had, well, not even that like the IBM consultant that deployed all of this originally wrote in K-shell to write the current occupancy of your data set on tape into a file, and then that file was consulted when it was deciding whether or not to stub data off into tape. And it's always been fragile, and it's always been a mess, and we've never really liked it. And so one of the original goals of the new PETA library was to fix this and to make it feel better, to make it, just feel on purpose instead of something that we hacked together. So I had heard of iRODS a while ago. The last site that I was at, I had a coworker who had used it at a previous job of his in the pharmaceutical industry. And he was just always saying, we should have iRODS. We really should be using iRODS. And I had never really, I definitely hadn't used it before, so I didn't really understand what it would be for, what the value of it would be. But it was interesting, and I trusted the guy, so I started playing around with it on the side in my spare time. I have a server just here under my desk that I keep kicking on accident that I've been prototyping on, and that's been very useful. But when we started designing this actual service, iRODS was one of those things that I thought, oh, maybe we should be doing this with iRODS, but we wanted NFS access, or basically file system level access that we could mount. And at the time, it didn't, iRODS was ready for that. And then it also didn't do the quota stuff. And it looked like we would be able to do that, but without NFS access. We're like, oh, we'll go somewhere else. We went with a proprietary competitor for this and many other features that were promised and didn't actually exist, which is part of why it's taken us multiple years to do this migration. So when that proprietary competitor to iRODS did not pan out, we reached out to the iRODS Consortium, namely Jason, and I think Taro was part of that conversation as well at the time, and started talking about what it would look to do this deployment with iRODS. And I think NFS Rods was like 0.7 or something like that at the time. Oh, this is coming. We thought, okay, that sounds encouraging. And then we gave our ideas for what it might look like to do what ended up being collection-based or now logical quotas in the iRODS rule engine or whatever, and got some good feedback on that. So ultimately, we put this aside for a little bit on the archive and focused on the active side and got that up and running, so that let there be time for some development, which was nice. But yeah, just in the last few months, we've kind of been pursuing this in earnest since the BGFS file system has relatively stabilized. So we've been early testers of NFS rods. We have it running on one server. I want to deploy it out into basically all of our data transfer nodes, the same nodes that run Globus. And I'm still kind of whiteboarding what that architecture should look like. I'm thinking of fanning our resource servers out there as well. But that's still in the early planning stages. And then, like I said, we had an opportunity to co-develop the logical. I mean, we didn't write much code. I messed around with prototyping a little bit during the when the logical quotas were just written in the traditional rule engine, but none of that actually got committed. Corey's done pretty much all of this, or all of it, as far as I'm concerned. And I want to say here that I can't overstate how responsive we found our interactions with the consortium. It's just been really great. We were kind of in a bad way when we came to the consortium for help, and it's been really good to get a lot of encouraging response from both of these features, but just in kind of figuring out how to deploy iRODS in general. And so, and that was even before we were consortium members. And I'm glad to say that we are consortium members now, and I expect that to continue for in perpetuity. Let's see. So this is what we have now in terms of the archive. We have our StrongBox LTFS thing for fronting tape. StrongBox exports a series of either NFS or SMB shares, and we do it all with NFS. And then these shares are mounted on our resource server, which right now is the same as the catalog server, but we might do that elsewhere in the future. And then re-exported or added into iRODS as resources. Alongside the iRODS catalog itself, all of this is fronted with NFS rods, with the main goal there being access to iRODS via Globus. And then, because it's what our users expect, we will also make those mounts available on our login nodes. And that's about where it ends for the archive. In the future, if we get active into this as well, we might mount this everywhere on all the computes and everything, but one step at a time. So another little bit of history is we were trying to work with getting access to iRODS with the current versions of Globus, and again, that didn't work out. And it's another place where we feel like the consortium really stepped up and helped us make this work. So we don't have this exporting via Globus yet, but it's just because it's early days with NFS rods, and there's no reason why we couldn't have those mounts there. It's just, actually, I think the mounts are even there. So it probably is technically there. We're using the data transfer nodes for some data ingest right now. So over here on the left, in our ILS resource thing, we aggregate those shares with a, what is it called? With a combined resource. I wrote this down here, but no, I don't see it. Yeah, anyway, they're children of a parent resource that randomly allocates files to one of four. And that is because the way StrongBox works, each share will only ever use one drive at a time. So doing it this way, it lets multiple users doing I/O across the whole system utilize up to all of the drives at the same time. And then we have these single and double parent resources because we also want to use this to replicate data from active, and the double resources are automatically replicating between two tapes in the background, and we don't need to replicate a thing that itself is already a replica. So we have that resource configured so we can just have a single copy of some data. So NFS rods is, I guess it's on Docker Hub. We're running it directly out of Git because we're making some changes. But ultimately, what is recommended and what we are doing is running it as a Docker container. We do it slightly differently then is in the README. So the README has you put a password and shadow file into the container, or mount it into the container, and that's where your ID mapping happens. But ultimately, that's just using NSS for your ID mapping. So we modified that container to install SSSD, and then we mount varlib SSS, which is where all of the pipes live, to connect the host SSS to the one running inside of the container, or to the libraries running inside the container. There's no actual SSSD in there, but that lets libnss SSS contact the host's SSSD and get all of the users that are in our LDAP. And by that, we can ID map any user in our domain without having to put them in all of our, in a static password file or anything like that. That just worked. It worked immediately, and I have a pull request for optionally having SSSD available in that container that is hanging open, but I don't think there's any pushback on it. There's just a lot going on. But configuration is largely these 3 files. Log4j is just a standard log for Java log configuration file, so I don't know much about it. We just copied it out of the example. And then an exports file, which is largely static, and the main stuff is the server.json. The original point of this talk is not all of the NFS Rod stuff, but for the sake of rhetoric, it's pretty simple. Again, we just copied it out of the example. But what I would say is that as we've been following development about NFS Rods, the format of this and other configure files, or which attributes are where and how they are spelled, has changed over time. So if any of you are setting up NFS Rods yourself, I recommend every time there's an upgrade to double check your current config over the example, because things like that were a big pain for us at one point, namely with this exports file. So the way NFS Rods does ID mapping is actually really cool. It's mapping, or sorry, not ID mapping, permissions mapping is really cool. It's exposing all of the iRODS ACLs as NFS v4 ACLs, but that is apparently a relatively new feature. And the original pull of NFS Rods that we got before we started before we started really testing it in earnest did not have that. So our exports line did not have this ACL bit either. And we had one on our system that we copied out of the example, and then it took us about a week to find that it was missing when things didn't work. We sorted it out eventually with a lot of help. So in general, I have a very polar experience with NFS Rods, which is when it is working, it is awesome and in ways better than I expected. So the example that I have given in the past is I didn't even know that iRODS had a POSIX kind of streaming API before. So I was expecting NFS Rods was just like caching a put and a get. But no, it's fully POSIX-y, and I was able to write a random file with DD onto it, and then use an offset of DD to do IO into a random chunk of the middle of the file. And it all worked exactly like it was supposed to. It was great. But it's clearly still early days. We, every now and again, when we're trying to do something that we hadn't done with it before, we're hitting bugs. Just in preparing this presentation, I found one, and then I filed another bug. So I imagine it will get sorted out, but it's clearly still relatively early. But I'm very excited about it. It is a great thing for it to have. And yeah, anyway. So logical quotas, which I think are the real point here, are also very cool. So it's deployed now as a, what is it called? A policy engine, as opposed to, so the original prototype was like a set of rules written in the iRODS native rule language or whatever. My understanding is the primary motivator for taking it from that to C++ was that we hit maximum size limit on the integers that rule language supports. So we were getting integer overflows with, since it measures the size of your data set in bytes, that overflows pretty quickly. But it's all working now, and it's pretty great. There's an RPM, and I assume a deb. We aren't using any deb-based distros, but there's a package available. You can install it. And then you just add this rule engine into your list of rule engines, and away you go. Okay, yeah, over here. So you can interact with it with the kind of straight native iRule command, but we took some examples that Corey had written up and committed into Git and wrote this tiny little iLogicQ Python script. It's like a couple dozen lines, but ends up making a lot of this very straightforward. We intend to contribute that into the repository. We just haven't gotten to it yet. But up here on the top left, you can see on our iRODS catalog server running as a user that is logged in as, I think, like RODS admin or something like that. We're able to start monitoring a collection. So this is my home collection here. And then list the AVUs defined on it, and it will only list the one, like this iLogicQ LS will filter down to the attributes that matter with respect to quotas. We can see that it is determined that there are 14 objects in there, and that's recursively. So if there's sub-collections, it will go find all of those and record how many data objects there are in that whole collection at the top of it. And same for total size in bytes. It sums up all of the sizes of all of the data objects and stores that at the top. And then the idea here is anytime you make a change, it checks to see if you're in a collection that is tracked, and then we'll update the values stored against that collection as you make changes. And we're finding corner cases here and there of things that aren't getting caught yet. I think I saw that Corey opened a bug recently for it not handling streaming I/O yet, but it's just a matter of catching all of the cases. It seems like it's relatively straightforward to add these in. So here we see that I have 14 objects in here. So if I set my limit to 14 and then try to put a file into it, so on the right, I'm me, logged in as me. If I try to put a test file into my collection, I get an error saying that doing so would exceed my maximum number of objects, which is exactly what we want. We care about number of files just because number of files on tape gets kind of dicey with like seek time and things like that. So for tape, we also want to limit what we tend to do is we have a ratio of size to number of files that we allow people to store to try and encourage them to pack things into larger files. But more normally, we have an example here. So I unset that max objects limit on the left as RODS admin, and I set a max size of 10 megabytes. Again, this is expressed in bytes. And I can see that that value has been set as a maximum size in bytes over there. And then I created on the right as me, logged in as me, a 1 megabyte file and just started putting it in there. And I'm using this weird syntax here so that each file is getting a new file name, so that it's a new file each time. But after I put in a few files, it eventually comes down to, oh, look, this would exceed your maximum data size. And exactly as you would want. And then over here on this last one, we see that the total size in bytes for my collection is just under 10 meg, as you would expect and as you would want. So as with NFS RODS, it is also clearly early days here. There are a few bugs in the tracker, but most of them are either corner cases for things that aren't being tracked yet, or little like permissions issues with who is allowed to set quotas and who can change quotas and things like that. But this seems like a much more straightforward thing than the NFS RODS stuff. So I imagine, again, that this will be that this will become production ready for us without too much additional work. This is on GitHub. The link for the GitHub for NFS RODS was on the slide back there as well. The biggest thing right now with the quotas is that it isn't integrating particularly well with NFS RODS, and that's not the streaming part, but that when we write into a collection with NFS RODS and it exceeds quota, it's just getting a generic IO error back. And if we look at the logs in NFS RODS, it's getting a trace back that it's just not handling. So hopefully it will be possible to actually pass like a quota exceeded error or something like that back, or at least handle that exception. But we'll continue working on that and submitting bugs and mostly sitting around lazily while we wait for the consortium to sort it out for us. That's everything that I have prepared. Like I'm happy to talk more about it and take questions. You're welcome to reach out to me after the fact also. There's my contact information, but what can I tell people about how we've set this up and what our experience has been like?
So I thank you so much. Is there, has anybody else touched it but you?
Me and the storage admin here. And I've done most of the configuration, but Patricia's doing all of the ingesting and things like that.
Right. And so has anybody else come up against the quotas stuff yet? I mean, you're testing the edge cases, but nobody's seen it live.
That's correct. Yeah. And even all of the ingesting that we're doing that without quotas, and then we'll apply it after the fact.
Okay.
So no, it's mostly just been me messing around with it. We did apply a limit to one of our larger allocations. Like this is clearly just like a test one that has nothing in it.
Yeah.
But it's been performant for backporting tracking onto an existing thing. Within iRODS and using the native commands, all of that seems to be working with the one caveat of there being a little bit of inconsistency in who is allowed to modify the attributes, but I imagine that'll get sorted out.
Right.
And also isn't a big deal. Our concern isn't adversarial users who might try and get around the quota system at this point. It's just, having there be something there that tells people they need to contact us and buy more storage.
Right. And so in terms of other clients, and by that I mean pieces of software that talk to iRODS, I was wondering if anything other than iCommands and NFS rods have been used to put anything in while logical quotas are firing.
Not well.
To confirm that they're behaving.
Yeah, so I expect we will also be very interested in TRiRODS. I have that in my personal environment, but I don't have it here yet. So we haven't tested it. Probably what I'll do is configure the logical quotas on my personal environment and start messing around with that there rather than try and get TRiRODS working for production at this point.
Right. I know that one question we're going to get about this is because of all the extra bookkeeping, what kind of performance hit does this affect? And I don't know how to measure that yet. You're our first hope for measuring that in a real way, probably.
Sure. I haven't looked at the C++ code, but it shouldn't be too bad because ultimately it should only ever be like an additional call during open and close, right? So I wouldn't expect it to add that much overhead. And it's ultimately just adding to an integer or subtracting from an integer.
Right. It's just, part of the slowest part of iRODS is talking to the database, probably. So
Sure.
The fact that we're doing that a couple times, it's going to be quick, but it's not going to be zero, right?
Yeah, and the our initial deployment here is for the archive, so the performance isn't as big of a thing. But it's totally fair that for if we wanted to start doing this to front the BGFS file system or its underlying ZFS, which is my ultimate goal, that's where we would really start seeing that hit. But yeah, we haven't tested any of that yet.
Right. Okay. Anybody else have any questions?
So you're using this so that you can get iRODS data also hoisted up into Globus via the NFS? That's kind of like your way of getting around the perhaps intransigence of the Globus consortium?
I mean, yeah, and ultimately I kind of prefer that solution, to be honest. It's just more it's more pluggable maybe, rather than having it be custom stuff everywhere. NFS is a common protocol, and plugging iRODS into Globus via NFS makes some sense to me.
Well, Cyverse is looking to do the exact same thing. And they know about it now because I just texted Nirav, but I think that would be interesting to kind of see how this works with that Globus constellation, and that might actually be a good use case for tuning. And it's always different when you see somebody else's software trying to go through your interfaces in terms of revealing corner cases and stuff like that.
So we have our current Globus, like our production Globus cluster, is a 3-node cluster that's really aging, and the CPU and memory is not keeping up with our demand. So we have another 4-node cluster that we've started building that isn't quite in production yet. My current thinking is, so right now we have NFS rods running on the VM that is also running iCat. What I imagine we'll do is run NFS rods on each of those Globus servers and then have them mount themselves for the NFS mount. And so then they all talk to iRODS in parallel. They aren't all going over a single NFS mount. And then I'm also imagining that we might move the resource servers for each of those StrongBox resources out of the iCat server, and which again is a weird funnel for all of that data to be going through, and move those to the DTNs as well, so that each of those resource servers is re-exporting NFS itself and in parallel with other servers, rather than having it all go through one.
Yeah, what we have not, I don't think we've actually plugged 2 NFS rods to the same catalog yet, but
It shouldn't matter.
It shouldn't matter.
No.
It's just a client. So
yeah,
famous last words.
I wonder, is there any like need for distributed caching between the nodes? Like at what level are you caching, and is there any?
In what software? In the NFS rods?
Yeah, well, like through something like a distributed cache for any, like in terms of performance tuning, I think that's really like the next frontier.
Than one, but
Yeah.
Yeah, I mean, the only concern we would have with cache would be coherency, and you know, they all have their own timeouts. And again, that's probably totally fine for the archive side of this. It might get into weirdness if we start trying to do it without it. But yeah, I feel the same. It really shouldn't matter to have more than one connected. At most, you might see a couple seconds where a file has been written into one and hasn't appeared in the other yet, but that's not unheard of with NFS anyway.
right, and we've got knobs for that. If you know that's a thing that you really care about, we can hammer the database more often. Excellent. Anything else? Jonathan, thank you so much. We will get this on the internet shortly. I appreciate it.
Thank you very much. I'm glad to have an opportunity to participate more on the community end. I want to be in more of those morning planning meetings and things, but it's just not working out with the schedule and the time difference right now.
Right.
Someday.
You're exactly 2 hours into the morning schedule. Yep. Understood.
All right, thanks everyone.
Appreciate it. Thanks.